This video demonstrates how to use R to run a large-scale wage regression. We start by the routine of setting the working directory. See the previous videos for the details about these initial steps. Open the new script window. The first few lines are exactly the same as what we had from the previous videos, so I'll be quick. Again, see the previous videos for details about these initial steps. Now we are loading the CPS data. Now we are formatting the data in the R's data frame. We construct the wage from earnings, hours, and week. We next infer the years of experience from age, years of education, and then number 6, the wage at which the compulsory education starts. Today we are going to focus on the subpopulation of individuals with at least 12 years of education. I mean greater than or equal. The dependent variable of interest is the log wage. On the other hand, the main independent variable of interest is the years of education. We want to include additional control variables, such as the experience squared. Since the squared experience is a huge number, we are going to divide it by 100. Now let's make a female dummy variable. Now interact the female dummy with the dummy of the union status. So we write the ampersand, and then the union status is equal to 1. Let's repeat this for man. So copy and paste and change 1 into 0. We next interact the female dummy with the dummy of the marital status. The marital status less than or equal to 3 means that the individual is married. Repeat it for men. And next we consider the marital status of widowed, divorced, or separated. These marital categories are indicated by the numbers 4, 5, and 6 respectively. And repeat it for men. We are now going to construct race dummies. Hispanic, the other categories are given by the race variable. 2 means black. Native Americans, Asians, and all the mixed races. We've got all the dependent and independent variables to run a regression for today. We want to now package all these in a data frame. Create an object called sub, and then invoke the data frame function to package all these variables. And we want to also select the subsample with the years of education greater than or equal to 12. So let's use these indicators to select rows of this data frame. So these lines package all these variables, select the subsample, and assign that to sub. Oh, actually, I need to also separate the variables by the commas. Now let's look at how the data looks like. This is very hard to see because the variable names are so long. For the visibility purpose, let's remove the variable names of the non-essential variables. The 4th to the 16th variables could be called the others. Now the data are much easier to see. The experience square and the dummies are called the others. Now we are going to extract the x portion of the data, that is, every column but for the first column, together with the column vector once. Here we are extracting all but the first column, in other words, everything but for the log wage. To allow for non-zero intercept, we also concatenate the column vector once. And we are going to call this n by k matrix X. On the other hand, the Y matrix is defined as the column vector of log wages, so we just extract the first column of the sub. Call this n by 1 matrix Y. Once we define the X and Y matrices, the remaining procedure to run the OLS will be the same as in the previous video. N is the first dimension of the X matrix, and K is the second dimension of the X matrix. We then define the XY matrix and likewise XX matrix. Now, the OLS is x prime x inverse x prime y here is the written specification. Next, we are moving on to the calculation of standard errors. The residual is given by y minus x beta. We are going to use the HC2 variance today, so let's compute the leverage values given by the projection matrix. The diagonal elements of this projection matrix are the leverage values. It's probably convenient to store the XX inverse. Now let's compute the middle part of the sandwich one. X transpose the diagonal matrix of the residual squared divided by 1 minus the leverage values multiplied by the x. We are now taking the sandwich form. The square root of the diagonal elements of this variance matrix gives the standard errors. For the written specification, this is the HC2 standard error.